Hello everybody, I am David Shipley Alexander. Welcome to my Infinite Energy series on YouTube. In my first introductory video, I defined infinite energy as usable energy provided by a non-conventional source. In my second, third, and fourth videos, I featured an emerging advanced energy technology known as LENR. That's an acronym for Low Energy Nuclear Reactions. And I presented, respectively, its history, commercialization, and application to space travel in those three videos. Video 5 presented a little-known model of the atomic nucleus, which may help provide a better theoretical understanding of LENR. In this, video 6, I present what I call mechanical propellentless propulsion. Propellentless propulsion is suitable for transportation on land, underwater, and through the atmosphere, but the lack of a propellant is, of course, extremely important for a space vehicle, because there's no need to carry mass all the way out to wherever to expel from the vehicle to provide vehicle motion in the opposite direction. However, propellentless propulsion systems do require an energy source in order to function. In my experience, it's quite common that people interested in advanced or infinite energy are also interested in advanced propulsion. For many decades, a number of inventors have described and/or patented devices which they claimed provided a unidirectional force, or saying it another way, these devices are reactionless. The word reactionless leads to and requires a statement of Newton's laws of motion, presented by Isaac Newton in 1686. Newton's laws of motion, as quoted from a NASA website, are 1. Every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed on it. Number 2. Force is equal to the change in momentum, m times v, per change in time. For a constant mass, force equals mass times acceleration, F equals ma. Number 3, for every action, there is an equal and opposite reaction. So my view is that Newton wrote about velocity, which is the first derivative effect, which is the change of distance with respect to time, for example, meters per second. And he wrote about acceleration, which is the second derivative effect, which is a change of velocity with respect to time. But he did not consider the third and higher derivatives, which inventors have built into their devices, as I will be explaining here shortly. In my view, Newton's third law of motion can be slightly modified to match what inventors have achieved by saying it this way: for every action there is an equal but opposite reaction, provided that third and higher derivatives are excluded. The influence of Newton on the history of Earth is, of course, huge, but scientific discoveries keep evolving. They are not static forever. I will be briefly presenting the work of a few inventors or scientists on this topic. There are more examples available. I begin with the work of Robert Cook Sr., who I met in 1981 in California. He passed away in 2008, but his son Robert Cook Jr. is now continuing and improving upon his dad's work. The original device was relatively large, about the size of several people, and carried weights at the end of an arm revolving in a horizontal plane. A second arm revolving in a vertical plane used ingenious mechanisms on the ends of its arms to detach the weights from the horizontal plane arm and then reattach these weights 1/2 a revolution later. Both arms were in continuous motion while the detaching and reattaching were occurring. A unidirectional force is produced by this machine because it is keeping an exchangeable mass on 1/2 of the rotation circle. The other half of the circle does not have centrifugal force for the mass of the circle where the mass is not there. An object moving in a circular path is experiencing acceleration, second derivative, but when the path of that object is changed, then the change in acceleration is third derivative or higher derivative effect. The entire machine has achieved a momentary, unbalanced, reactionless force. Sometime in the 1980s, Boeing Aircraft agreed to test Cook Sr.'s machine, but with extreme reluctance because they knew it could not work. But they tested it, and it did work. It provided a force in one direction. The second machine I discuss here was invented by Brandson R. Thornson. He called me a number of times from approximately 1999 to a few years later while I was researching information that would become part of the NASA contractor reports I was writing. Thornson's device, and here I will use a sketch to explain it better than a whole lot of words. And this is somewhat simplified. And what he has here is two gears that are meshed. They're driven from the back. This lower gear is fixed and the upper one is constrained so it will keep meshing as it rotates and revolves around the lower gear. Now in addition to that, there's an arm coming off of this upper gear with a lead weight, small mass on the end of it. So as the upper gear rotates and revolves, we're interested in the path of that mass, and it's called epicyclic motion. And we see it looks a lot like a circle in the upper part. Then it comes down to the bottom as its radius contracts, makes a little loop, comes around and back up. Now he really had two of these working side by side, and the one is going, the weight is going one direction, and the other it's going the opposite direction. And that balanced out the sideways forces and vibration, and the resultant was the force moving up. The path traced out by mass m during one revolution of the upper gear has a large radius for half a revolution, high centrifugal force, and a small radius for the other half, low centrifugal force. I mentioned the mirror image device working beside the other to dampen out any vibration. A YouTube video shows the Thornson device with an electric driver motor and battery for energy, all in a closed wooden box within a canoe carrying two men being propelled in a swimming pool. Nothing in the box was accessible to water or to external air. Dr. Tom Vallone of Integrity Research Institute, I have known him since 1981, has stated that the thrust-to-power ratio of the Thornson device is 20 times higher than the thrust-to-power ratio of engines that powered DC-9 aircraft. This ratio must be understood at the apparatus size level. For now, we haven't created the apparatus, but the numbers are there. Another example of a propellentless propulsion device was described in a patent by Alexander Kidd, which uses the principle of scissoring gyroscopes. The angular orientation between the axes of two active gyroscopes is made to change, causing a relative third derivative effect between them, which results in a reactionless force for the entire machine. Saving the best for last. Dr. Tom Vallone, who conducts periodic scientific conferences on breakthrough energy and propulsion technology, was extremely pleased in 2012 when a speaker, Mike Gamble, an engineer from Boeing, concluded his lecture by stating that it was not classified information and he had cleared it with his management, and then gave Dr. Vallone a photograph of the formerly secret propellentless, that is, reactionless device that he said Boeing had been using for years to maneuver its orbiting satellites. He said it used the principle of scissoring gyroscopes. Is it possible that all of the four named examples are playing off of one single force we have yet to completely define, or a combination of forces, or each on their own? Regardless of the answer, these are examples of the third derivative effects that required us to tweak Newton's third law. What do you think? Thank you for leaving a comment or question under these videos, subscribing, and leaving a thumbs up. I have many ideas for future videos, and what I would call electrical propellentless propulsion is trying to push to the top of the list. Have a look and see. Thank you very much for your attention. Until the next time, I am David Shipley Alexander.